Good afternoon, everybody. Welcome to class today. Thank you for joining me, whether you're joining me live or you're watching the recording. I appreciate you watching. First of all, today, my apologies for getting the stream started roughly 5 minutes or so late today. Had a little meeting before stream today that went a little longer than I expected it to. But that's all good. We're pretty close to being on time, right? And we'll take the time that we need to get through our material today. Remember that we are talking about the module, a module ahead, right? So module 3 is the module that we are still in. It is the module that ends today. But we are talking about module 4 material in our live stream today. Right, and module 4 gets us into conditionals and recursion. right? So the idea of recursion is a big deal, and we need to have conditionals in our back pocket in order to be able to do that. So in addition to these topics today, we'll keep on practicing the things that we've learned over the past several weeks. And we are going to introduce a new best practice that is going to be a requirement that I expect to see in all of your programs going forward. I mentioned it in the module as well. I believe it's called the main gate. And we'll see how all of that works. And that's the big plan for today. I am currently caught up in grading, right? So I've got all your Module 2 stuff graded. Don't forget to check the feedback on that. Even if you got full credit, sometimes I include a little bit extra in there to kind of give you some extra information about maybe some things that you could have done better or some things that, maybe didn't work quite as well as you might have hoped, that sort of thing. So you want to check that feedback. You never know. So Module 4, which will be starting tomorrow, is about conditionals and recursion. So the first thing that we want to ask ourselves is, we want to define some terms. So we're going to start off by defining the term of what is a conditional. And so really a conditional, all it does is it allows our programs to make a decision. It allows our programs to make a decision. So this is where we get into a real crux of how our programming logic works. Right? I'm able to take a singular program and have it branch off into multiple directions, right? Like previously, kind of everything that we've done just kind of works from top to bottom. So it's one thing and it does it, and then another thing and it does it, and another thing and it does it. With a conditional, we're actually able to allow our program to branch off into different directions and do different things based on whether or not a condition is true. And that's also kind of what the discussion boards of the first 3 modules have kind of been driving themselves towards. Right? Is this idea of true and false and kind of the way our computer thinks, so that when we move into Module 4 and we're looking at conditionals, we're able to more closely think about the way that our computers are making these decisions, so that it can kind of inspire us to write better conditions in order to help our computer make the right decision. And so another big thing that we can kind of think about as we're entering into this, right, and just kind of a side note really quickly, right, the discussion boards change starting in Module 4. You'll want to have a look at those. Right, we start doing code review as the discussion board, as our, because along with conditionals, this is kind of the point where the big programming assignments start to get a little bit tougher. Right, first 3 modules overall relatively simple. Right, in Module 4 they start to get a little bit tougher. So one of the things that I want to encourage you all to do is kind of help each other and review each other's code and work together in terms of all that. So that is something to kind of pay attention to. But when we're dealing with conditionals, it takes this sort of straight line structure and breaks it into something that can branch off. And we can have different types of conditionals. We can have nested conditionals, or we can have chained conditionals. And that just changes how the things branch, right? Like if we have a chained conditional is a condition that branches off into a bunch of different conditions where you can go down into a bunch of different paths. A nested conditional would be like a condition inside of a condition inside of a condition. And all of these have sort of their own place in terms of how things work here. So we'll be talking about these sorts of things as we kind of progress. So with conditions, right, we are talking about our program making a decision And so if something is true, basically, we want our computer to do something. Right? Whatever that may be. Right? That's, we want our computer to execute a specific sequence of statements in the event that something evaluates to true, or, maybe if that doesn't evaluate to true, it'd be something that evaluates to false. Right? We have some of these proposition statements that we've been talking about that are unambiguous, that are either true or false, that a machine can look at and make a specific determination. Yes, that's true. Yes, that's false. Let me go from here. And so we have to have at least one statement, at least one line of code inside of each conditional branch. Right? So we can have an if condition. If we have an if condition, we need to have one line of code for my program to do if that condition is true. If we have an else condition to go along with that if condition, we need to have at least one line of code in that. If we have any elifs in Python or else if conditions, each of those elifs have to have at least one line of code. And as we just mentioned, we can chain conditionals, which when we're chaining, we're talking about if, elif, or else. We can have as many elifs as we want in a chained conditional. And when we're thinking about else in this sort of way, and we'll do demonstrations to kind of help us make more sense of this a little bit later on. But else basically just means all other conditions. Right? Anything that doesn't match any of my if statements or elif statements. If everything else rings false, then run my else statement. Or nested conditionals, where we have conditionals that are inside of conditionals. And this creates what we would call a decision tree. Right? Now, something to notice here, right, as we're looking at this sort of half pseudocode here for our syntax. We started talking about something last week when we talked about functions, and that was the presence of this colon. And we said that if a line has a colon at the end of it, then that means that it has other lines that belong to it. There are other lines that go with this if statement that will run if this condition is true. And we can see here that we also indent this underneath the if statement to show that it belongs to this if condition. It's a part of that if condition. And when we're ready to write code that's outside of the if condition, we just backspace and we write that line of code even with the letter I in if. Now, one of the things about conditional expressions or if statements is that they utilize propositions, right? They utilize something that can be defined as either true or false by our computer. And so we call these Boolean expressions. The idea of something being Boolean came from a mathematician by the name Boole, who basically said that every mathematical equation can be broken down into a series of trues and falses. Right, so conditions are written as Boolean expressions. Now we do have a key difference here in terms of something else that we've looked at previously. Right, when we assign a value to a variable, we use one equals sign. One equals sign in programming is an assignment, right? It is setting one value equal to another value, or one variable equal to a value. When we're talking about a Boolean expression, we use two equal symbols. Two equal symbols is for a comparison. So one equal symbol is for an assignment. It's basically saying this variable is equal to whatever we're trying to put into it. Two equal signs is a comparison, which is basically asking the question, is the left side equal to the right side? Right, so we see an example like we have here. 5 equals 5. Now, obviously, right, if we were looking at 5 equals 5, we have these two equal symbols here. And that's checking our comparison. And it is true that 5 is equal to 5. So my computer is going to evaluate that statement to be true. Now, the terms true and false are special values. They are reserved syntax that belong to the type bool, B-O-O-L. And so they're not strings. So since they are not strings, whenever we are using the Boolean logic trues and falses, we don't have to wrap them in quotes because they're not strings. Right, so equals here is one of our relational operators. And so we have these different relational operators to show whether or not something is true or false. Right, so we could say x not equal to, or x is not equal to y. Right, so if we said, 5 not equal to, or 5 exclamation point equal to 7, then the statement that's being made there is 5 not equal to 7? Which that's true, so that would evaluate true. If it was 5 not equal to 5, right, the question that's being asked there by our computer would be, is 5 not equal to 5? In which case, that's not true, that's false, right? X is greater than y, x is less than y, x is greater than or equal to y, x is less than or equal to y. So these are all different operators. Are not equals, are greater than, are less than, are greater than or equal to, are less than or equal to, that form comparisons, just like our equals here. Now, there are instances, right, and this gets us our proposition. There are instances when we may need a complex proposition. We may have multiple things that could be true or could not be true, right? And in those cases, we use logical operators. And so we have 3 logical operators in Python. They are and, or, and not. And when we're thinking about them semantically, we can basically think about them in the same way that we would think about English, right? So if we use the term and we have 2 sets of comparators to link that are linked by this term and, then both of those sets of comparisons must return true in order for that statement to be true. If it's either one or the other, it's going to be or. And then the term not, which negates the equality. And so these are those complex propositions that we were talking about a couple weeks ago. And we can see these logical operators, right? We use these logical operators on our truth tables in Module 3. Right? So now we can kind of see how, over the last 3 modules with that sort of higher level, complex, logical calculus that we had been working with there, how it relates to what we're talking about here, right? Like it was all kind of building. And so I've got some examples for us to do and some different things for us to do. And I want to have enough time to where I can also explain recursion. So what I'd like to do here is just do some simple examples, work with, and then go back and work with some recursion. All right, so let's start out by how we normally start out. We start out by using our shebang. So that is hash bang /USR/bin/env Python 3. And I'm going to take my different examples here and I'm going to put them into functions. And so let's create a function def. We'll call this one basic underscore condition. And we'll put our parentheses there at the end to signify that it is a function with the colon after that. Now that indicates that there are things that are involved with that belong to my basic condition function. So let's create an input variable here, right? We looked at inputs a little bit last week. So I'm going to create a variable. I'm going to call it num. So let's create a variable called number or num and set it equal to the integer typecasted value of the input. Enter a number. And so now what I'd like to do is check to see if this is bigger or smaller than another number. Right? Let's say 50. Right? So remember that, like, for example here, right, you can see that my cursor, my blinking cursor, has gone backwards. So when it's gone backwards like that, I am no longer in my function. So I need to hit tab to make sure that I am one tab level underneath my function to show that this conditional statement belongs to this function. And so now we can write if num greater than 50. If num greater than 50. And we put the colon at the end of that. And so when I hit enter here, you can see it tabs over again. Right, so if we look at this, right, we can see that this if statement belongs inside of this function. And now we're going to have statements under this if statement, which in turn belongs to the function. So in Python, we just keep tabbing over. It's a little, I mean, really, they both have their sort of pain points, right? If we imagine, other programming languages, because other programming languages will typically use like nested curly braces, which one of the easiest things, in my opinion, in, say, JavaScript or Java or C++ is to forget a curly brace or accidentally delete a curly brace. And they do kind of get a little jumbled up and a little tougher to see. But it is also fairly easy to get out of alignment with your tabs. So it is something that you want to pay extra close attention to, that you are working with these tabs and make sure that each line is tabbed under something that it belongs to. So in this instance, we're going to print big number in the event that that number is bigger than 50. And so from here, we can write an else statement, right? And so my else statement does not belong to my if statement. It's its own thing. So I'm going to make sure the E in else is on an even playing field with the I in if. And else, we said else is all other conditions. So anything that, if this is not true, then else automatically becomes true. So it does not get a proposition to be added to it. So in this instance, I want to print something else. We'll print small number. Right? So we have our big number here and we have our small number. And so now we need to call our function in order for this to work. Now, before we call our function, I want to introduce you all to a brand new topic. Let's talk quickly about the main gate. The main gate. The main gate is a big thing, right? You know, one of the things that we've kind of harped on when it comes to variables and functions are the fact that it helps your code become modular. And so the main gate helps your code be even more modular. Right? Because essentially what the main gate does is the main gate allows you to execute code from the file that's being run and not code from other files. So essentially what we're doing with the main gate here is we're kind of putting up a fence, we're putting up a gate, right, between our functions and the code that's actually calling those functions and running things. Right, so this way we can take functions that we know already work and import them into other files without it running that code. Right, and I guess I could show you all an example of this pretty quickly. So let's say I put in a little call here for basic condition. And we run this. It's going to run that condition. It's going to ask me for a number. I'm going to put it in 23 and it's going to say small number. Right, well now let's say I create a new file over here. And I call this file maybe second.py. So now I have another Python file. And in this Python file, I can import main. And I can run main dot basic condition. And it can see that basic condition. Right, now Replit runs this stuff a little weird, right? Whenever I push this green run button, it's always running the main.py file. If I want to run a secondary file, something that's not main.py, I need to come over here to the shell. But I can run a secondary file from the shell. Right, so let me Python second.py here in my shell. Now we can see, okay, it's asking me to enter a number. And I can enter a number like 56, and it's going to tell me that's a big number. And then it says to enter a number again. Hold on a minute. Like I ran this file that's just calling this function one time. Why is it asking me to do it twice? And it's because of this basic condition that is not behind a main gate here in my main file. So we have a special reserved term in Python, which is in quotes underscore underscore main underscore underscore. Like that right there. And that is not referring to a specific file. Right? That is only referring to whatever file you're running. Right? Any file that you're running, regardless of what it's named, is underscore underscore main underscore underscore as a reserved name in Python. So this is another thing that kind of people struggle with. The fact that this is main.py and the fact that this is main have nothing to do with one another. Right? So I can write a condition and say if underscore underscore name underscore underscore equals equals, in quotes, underscore underscore main underscore underscore colon. Then we do this. So, right, I have it tabbed in one space because this is a conditional statement. This function call belongs to this condition. Right, so now if I run this main file, it's still going to work. Right, and I can still do my thing, and I can enter a number here, and it'll tell me big number or small number. But the difference is if I go to this second.py, and in my shell I run second.py again, I had a little hiccup there. Let's see if it'll... A little hiccup here with Replit. Let's see if it'll go. Let's see here. Python second.py. Enter a number. Let's say 45. And then it stops. It doesn't duplicate it like it did here, because this call here is locked behind the main gate in this file. So when I run this file, it is only running this call. Right? And so this is a best practice that we like to see. Helps to make your file more modular. So this main gate is something that I will be expecting to see in your programs going forward. Right? It basically allows me to take, make a bunch of functions, do a bunch of stuff here, and then I can use this same file in other files if it's successful, right? Which is a huge deal. So let's write another function here for a chained function. Chained condition rather. And if we were doing this realistically, we would actually do this to where we could just put our input here behind the main gate and then pass it into our other functions via arguments. So we do it something more like that. For simplicity's sake here, let's change that. Just so that makes sense. So this red squiggle here is because I've started a function and haven't finished it. We'll use our arguments here to bring a num into this, and we will say if num greater than 100. We'll print very big number. So we're chaining these conditions, right? So in a chained conditional, along with my ifs, I'm typically going to put some sort of elif. So elif is an else if. So if this item isn't true, maybe this one is. So elif num is greater than 50, let's say. Num is greater than 50. In this case, I can print big number. Right? So what's going to happen here is it's going to evaluate it against this statement. It's going to see whether that number is bigger or smaller than 100. If it's bigger than 100, that's going to trigger true, and it's going to print very big number. If it's not bigger than 100, it's going to check this statement to see if this statement's true. And then we can add an else in here to cover all other statements, and we can print small number. like so. So now if we call this function, right? Call it down here. We can call our chained condition function. Chained condition. We can put that in there. And now when it runs, it'll run our line here to get a number from us. It'll chain the condition. And then it'll run chain condition with that n as our num parameter. So first number, we can say 127. That's a very big number if we run it again and do something like 75. That's a big number if we run it again and do something like 32. That's a small number. Right, so what if we wanted to check to see, well, for sake of time, let's just reuse this code here. And what I'd like to do is I'd like to check to see if my number that I enter it in, if it is a big number, then I'd like to check to see if it's even or odd. All right, so let's try that out. And we'll do that with a nested conditional. So it's def nested condition. We're taking a num value into that as well. We're going to use that same code that we've used previously. If num greater than 50, print big number. Got a little bit off the tab lines there. We need to make sure that all is where it needs to go, right? One tab for the function, 2 tabs for the if statement. But now here under the if statement, I'm going to get rid of this print, and I'm going to put another if statement. If num modulo 2 equals 0. And so we've talked about the modulo operator before. Like, that gives me the remainder of a division problem. So if 2 goes into num evenly, then that means it is an even number. So I can print even number. And then if it's not even, then it only has one option. It can be odd, so we can print odd number. Right, so now if we run nested, tab it over because it's under an if statement, nested condition with the value of n, whatever that input value is, being passed into it as an argument. Like so, enter a number. If we enter any number over 50, it's going to evaluate it to be even or odd. So if I say 56, it's going to tell me it's an even number. If I say 59, it's going to tell me that's an odd number. And if I do something less than 50, it's going to tell me it's a small number. So this is an example of a basic condition, a chained condition, and a nested condition. All also done behind a main gate. So I'm going to kind of clean this up a little bit under normal circumstances, right? I typically have like a lot of extra like blank lines in here just to keep things clean and easily readable, but I'm writing a lot of code in this file, so I'm going to kind of get rid of some of those. Because I want to talk about recursion a little bit before we go today, and that's going to take us some time. So let's talk recursion. Now that we know two things, we know functions that we learned last week, and we know conditions that we learned this week, we can start to work with recursion. So what is recursion? Recursion, just in general, describes a problem that we kind of face in every area of our lives, right? Anything can be recursive. And when we're talking about things that are recursive, we are talking about things that are defined in relation or described in relation or in terms of themselves. Right? You know, you can kind of think of like the definitions in like the dictionary that where they say like you know, some kind of adjective maybe. Trying to think of a good example off the top of my head. Like if I'm doing, you know, if I have something that is, you know, you look up expertly, and the definition of expertly is, you know, having qualities of an expert. And so, like, the term you don't really know is expert, right? It's kind of recursive in defining the term that's essentially expert with the term expert. Right. Actually, you know, one of the cute things that I've seen done before in programming books is that it'll have a reference to recursion in the index on the index page that it's on. So like if the index page is 289, it'll say recursion, page 289. And you just go there and it's a reference to recursion on that same page. Right, so anything that we do recursively can also be done non-recursively, which is iteratively. We'll talk about, you know, iterations in the future. The equivalence of recursion and iteration does not say that it's as easy to do one method as it is the other, and some problems require recursion or iteration as a means for a solution. Right? There are what we call 3 laws of recursion. One is that there must be a base case. There must be something that is being checked by our conditional statement for where if that statement were to no longer become true, then it stops running, right? So there must be a base case, a path through which the code won't call the function anymore, right? Something that breaks the condition. There must be a recursive case. A recursive case is a call to a function within itself. And there must be a means of moving a value toward the base case. So something that will, if it's true, keep the recursion going. But if it's false, trigger this base case where the path doesn't run again. And if that doesn't happen, right, we end up with an infinite loop. Let me show you what that looks like. Right, so let's say I write a little function here. We'll call it def hello. And we'll print hello world. And then we will call hello inside of the function. Right, so I have this function hello. It's going to print hello world, and then it's going to run itself. Right, that's essentially what recursion means, is that it's a function that runs itself. So if I call this function behind my main gate now, hello, let's run it and see what happens. It's going to just keep running hello world until it triggers the Python recursive depth error. Python actually beneficially has that built into it to where it doesn't, like it crashes the program without breaking everything. Right? If you end up with a recursive call in something like, say, Java, you might end up with what they call a buffer overflow, which is an overflow of memory, which can cause even bigger problems than just the program kind of crashing, right? So we don't want to do that. So what we want to do instead is we want to take this value and we want to move it in such a way that we can get this to stop, right? So let's say hello here. Instead of not having a parameter, let's say it had a parameter n. Okay. And then in our recursive call, what we do in turn is we manipulate that value n to where it's not as big as it once was. Right? So let's say n minus 1. Right? So it goes through, it's 10, it's 9, it's 8, it's 7, it's 6, it's 5, so on and so forth. Right? But in this case, it's still going to run forever. Right? Just that n value is just going to go down to negative infinity. Or it would if I don't include an if statement. So I can say if n is greater than 0. In that case, do these things. Right? So if I call hello here with 10, it's going to pass 10 as the argument, value for n. So n equals 10. 10 is greater than 0. Yes, it'll print hello world. And then it'll take n and subtract 1 from it and feed that back in as the value of n. So now n becomes 9. Right? So if I run this now, I get hello world here 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it stops. Right? It's a recursive call. And through the power of my functions and through the power of a condition, I'm easily able to do this recursion. And I can do it as much or as little as I like, right? Like if I go here to and make this hello 5, it's going to give me hello 5 times. I could also invert this and go the other way with it. Right? And so maybe instead of if n is less than 0, I can say if n is less than or equal to 10. And instead of hello 5, I can start at, say, 1. And it'll count up from... Oops, I'm still subtracting 1 here. I meant to add 1. I meant to invert that logic. I need to invert that logic. And so if I invert that logic and do like I'm supposed to do to where I'm progressing that toward 10, right? Because if we leave it at as minus 1, it's still taking it away from 10, which it'll never get to there, right? If I'm increasing this to make it closer to 10, it's going to give me 10 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if I add a reference to the value n here, so we do a little bit of concatenation here. I can take the string typecast value of n and concatenate it to maybe period space hello world. Then not only will it print all these 10, it'll count them for me and show me that I have 1 hello world, 2 hello world, 3 hello world, 4 hello world, 5 hello world, 6 hello world, and so on and so forth. Right, so we can do a lot of really fancy things here. We can do a lot of stuff with recursion. Right, as we're kind of getting started here, the only thing that we're kind of doing with it is sort of counting, right? So this is kind of a good way to think about it. Because we're just ensuring that we run a particular condition a set amount of times, right? We can just kind of move, in this case, we can kind of move this value to wherever we want it to be, or we can take another value, call it like y, and have that be the upper limit. Right, so in this case, maybe I use this n here again. Remember, n here and n here is not the same n. They're two different n's because they're scoped to the function. I can go 1, comma, n. So in this case, the value n from my input here would get passed through as this, which would get put in the y position. And 1 gets put in the n position. So it would be 1 is less than or equal to whatever value our user enters. So let's run this, and we can enter, like, say, 25. Oh, we also have to put the call here in when we call it recursively. And so with our y here, we actually don't want it changing, so we can just leave y static, right? We want it to remain 25. Right, so in this case, y 25, and we get it 25 times. And so in this instance, what we've done here is we've just created a program where you can enter any number, and it'll print out hello world that many times and number it for you, right? And so, like, if you ever got in trouble at school and, you know, you had to write a certain phrase like, I will not, you know, like, I will not slam my book closed. Right, and you had to write that 100 times. Well, now you can write it 100 times and have proof that you can hand to your teacher. Right, and so that's a fun little thing using recursion there, right? We can see exactly what's going on here when we're doing this. It's taking the value n, which starts off as 1, and when it recalls it, it's adding 1 to that value, and then it becomes 2. And then after that, it becomes 3 and 4 and 5 and 6 and so on and so forth. So normally, during this live stream, and we did get started a little late, so I think we will go a little bit over today so I can do this. I do a little conditional example, and we can also make it recursive if we want to. And that is to determine whether or not a year is a leap year. So let's look at this algorithm really quickly. It's a fun algorithm, and it's an algorithm that determines whether or not a year is a leap year. A leap year has 366 days to compensate for the fact that it doesn't take exactly 365 days to fly around the sun. It takes 365 point some strange extra little bit there. You know, you can kind of say 0.25, but even that's not quite true. But we can look at these 5 steps here, and really it's only 4 of them that are, or 3 of them rather, that are actually doing something. So if the year is evenly divisible by 4, we go to step 2. So if the year is evenly divisible by 4, we check to see if it's evenly divisible by 100. So that's a nested condition, right? If year modulo 4 equals 0, we check to see if year modulo 4 or modulo 100 equals 0. If that's true, we check to see if year modulo 400 equals 0. And we say whether or not something is a leap year. So if the year is evenly divisible by 4, we keep going. If it's not, then it's not a leap year, right? The first big criteria is that the year has to be divisible by 4 to be a leap year. If the year is evenly divisible by 100, go to step 3. We got another thing to check. But if it's evenly divisible by 4 and not evenly divisible by 100, then we can go to step 4, which means that the year is a leap year. So if the year is evenly divisible by 4, evenly divisible by 100, we have to check to see if the year is evenly divisible by 400. If the year is evenly divisible by 4, 100, and 400, then it is a leap year. If it's only evenly divisible by 4 and 100, but not by 400, then it's not a leap year. Right? As you're watching this, I kind of encourage you all maybe to kind of pause, look at this, and maybe draw a map out to try to see if you can make sense of this. Right? This is one of those things that I'd kind of like you coding along with me. So if you're watching the recording at home or you're here with me live, if you're here with me live, you can kind of follow along with me. If you're watching the recording at home, I want you to pause, try to map this out first, just wrap your head around it. And maybe even try it out and see if you can figure out how this works, and then you can replay the video and see me do it. Right? I encourage you all to do practice like this. So let's look at this. I'm going to comment this out. I'm going to comment this out. I'm going to create a function called def leap year. And we will be bringing a value into it. We might be bringing 2 values into it. In fact, let's start off with just our first value. We will be bringing another value into it a little bit later on. So let's have a value y for year. And so now we can start our conditionals, right? If y modulo 4 equals 0, then we're going to need to check something else, right? That's what we said. So what was the other thing that we said? Well, if y modulo 4 equals 0, we go to the next step, which is to check to see if y modulo 100 equals 0. Right? We've nested this conditional. And so if that's true, we're going to go to check to see if it's divisible by 400. So if y modulo 400 equals 0, well, then we've finally gotten to a place where we can say print leap year. Right? Because if it was divisible by all 3, we said it's a leap year. Now we can kind of work backwards with our else's. Right? So our first else goes with the y modulo 400. So in this case, it is print not a leap year. Now I want to go back to be lined up with the previous if statement for an else statement. Because in this case, if it's evenly divisible by 4 and it's not evenly divisible by 100, so if this statement isn't true, but this statement is, then it is a leap year. And then finally, we need an else statement to go with that. If it's not evenly divisible by 400 to begin with, it is not a leap year. Right, so we can see that the ifs and the elses that are on the same line are even with each other in terms of their tab spacing. Right, and we can see, like, this is what I was talking about earlier. Right, when I was talking about things that, we want to make sure that everything lines up properly. And so that gets us the base of our program, right? So let's create an input variable here. We'll call it year. And we'll say int input enter a year. And we'll put that year in as the argument to our leap year function. Right, so for example, if we were to put in this year's 2023, it's not a leap year. So we know it's not a leap year. Next year, on the other hand, 2024 will be a leap year. So we can do that. We can see that it is a leap year. Now, what if we wanted this to keep on working until we didn't want it to work anymore? Right? We wanted to keep on running until we're tired of it running. We can do that. Right? And we can do that recursively. So in this instance, what I want to do is I want to have a y here, and I want to have a check. We'll call it C. Right? And so I'm going to write a conditional statement here to say if C equals yes. Now, since we've added a new if statement here, that means we need to take all of these other conditional statements and tab them over one more time. So all the ifs, all the elses, and everything underneath them, we need to take all of those lines and tab them over one more time because they now all belong to this new if statement of the if C equals yes. And so along with every print statement, what we're going to need to do is we are going to need to put an input that is going to reassign the value of C. So C equals input, try again, question mark, yes/no. Now, we're not going to talk about data validation quite yet. We will talk more about data validation in the future. So right now, we're just going to assume that our user is smart and they're going to do the same thing every single time. And I'm just going to add this one statement to all of these. Now, what I would need to do here is check this C. Right, actually, I wouldn't really need to do any of this, right? This is kind of overcomplicating it just a little bit as the more I think about it. I don't have to do it all here. Because if I was smart about it, I would put it all at the end here. So regardless of what happened with the rest of the stuff, I can check it once. So now we're going to check to see if C equals yes, and we can actually run a if C equals yes. We can get another year input. And say year equals this. And technically we wouldn't need to make this call here if we were doing it here. But that's fine. Right, just to get us some practice. So we can say, we can make our recursive call to leap year. With year and whatever value is in C. And that is not, that doesn't belong to that. That's just a, so we get the value, we get a new value for year, and we recursively loop our function. And so that means that we have to take our initial function here and seed it with a yes, so that it brings in a yes to start this function. So when we do that now, we can check things multiple times. Right? Enter a year, 2023. Not a leap year. Would you like to try again? Yes. Enter a year, 2024. It's a leap year. Would you like to try again? Yes. Recursive call. Let's go. 1800. Is that a leap year? Nope. Would you like to try again? No. Right? And that's going to give us that condition that breaks it, and so we're going to stop. Right, so again, we could simplify that a little bit. Right, I was kind of going a weird way with it just to give us some more practice. Right, if we took, because we really only need to check if C equals yes here, but we still need to be able to pass it through. Right, so it's kind of weird, but it's okay. Right, like that's our leap year function. And so that's all that I have for you today. Remember, this is module 4. So module 3 is due today. The stuff that we learned kind of today, that's due next week. If you have any questions, if you're here with me live, you can go ahead and start putting them in the chat. If you are watching the recording, send me an email or a Teams message, and we can sort it out. We can figure it out. So we'll just hold for a moment here just to see if anybody here with me live has any questions. I covered some pretty heady topics in not a ton of time, so there might be a question or two kind of hanging out there. All right, since I'm not seeing any at the moment, so whoops. Yep, yeah, if you come up with something later, you certainly can. A lot of stuff covered today. We'll let this be for today then. Thank you all for watching. We'll see you next time.